It's kind of crazy how much of our world feels virtual now, almost magical. We tap a button, send a photo, and poof, it's halfway across the world. But have you ever really stopped to think about what's physically happening behind that screen? What actual machinery, what incredible amounts of energy does it take to power this seamless digital life we all take for granted? Well, let's pull back the curtain and see what's really there.
So meet Rebecca. The very moment she was born, something else was born right alongside her, her digital double. A photo gets taken, an email gets sent to the family, and just like that, she exists in two places at once, the real world and the virtual one. Her name, in the language of computers, is just a string of ones and zeros. It's a perfect little example of how our lives are instantly mirrored in this world of data. But that data has to live somewhere, and it has to travel.
So what really happens when you hit send? It's not magic, it's a journey. On average, that email travels 15,000 kilometers, pretty much at the speed of light. It zips through fiber optic cables under our streets, hits a switching center, and then gets shot out onto this global superhighway of cables, many of them running under the ocean. Its destination? A massive industrial building, a data center, where it gets processed and stored before making that entire trip in reverse to your friend's inbox. All of this in just a fraction of a second.
Now that destination I just mentioned, the data center, that's where the real story begins. We like to call it the cloud, but it's not some fluffy thing floating in the sky. It's on the ground in these huge, anonymous buildings. You could call them the internet's factories, and we're about to go inside.
Okay, so what is a data center? It is a very real, very physical place. It's basically a purpose-built warehouse that is jam-packed with tens of thousands of computer servers. These are the machines that store our photos, run our apps, and process every single one of our online transactions. You can really think of them as the fortresses of our digital economy.
The number one rule of a data center: it can never, ever, ever turn off. The internet doesn't sleep, so these places demand a constant, massive, and totally reliable flow of electricity 24/7. To make sure that happens, they have rooms full of huge battery backups called UPS systems, and often massive diesel generators on standby, ready to fire up the second the power flickers. Okay, now think about the heat that comes off your laptop when you're working hard. Got it? Now multiply that heat by, say, 50,000. The inside of a data center is basically a furnace. So to stop all of that expensive equipment from literally melting down, they need industrial-scale, round-the-clock air conditioning. That constant blast of cold air is just as vital as the electricity itself.
The absolute biggest nightmare for a data center is a crash that could lose our data forever. So to prevent that, they basically double or even triple everything. Every critical server, every power line, every cooling unit has a backup ready to take over instantly. It's like having a spare tire, not just for your wheels, but for your engine, your steering wheel, every single part of your car. In the industry, they call it N+1 or 2N redundancy. It's fantastic for reliability, but it also means a way, way bigger energy bill.
Just let that number sink in for a second. 40%. Almost half of the absolutely phenomenal amount of electricity a data center burns through isn't even for running the servers. It's just for the air conditioning to keep the machines from overheating. The price of keeping the internet cool is just staggering.
So, right, all this power, all this cooling, all this backup equipment, it adds up. Every single click, every search, every stream has a hidden cost. So now, let's take a look at the energy bill for our digital lives. And fair warning, it's a lot bigger than you probably think. This is honestly just mind-bending. Let's take just 1 hour of global email traffic, just emails. The energy it takes to send and receive them is equivalent to the entire output of 50 nuclear power plants for that hour. Or burning 4,000 tons of crude oil, or flying 4,000 round trips between Paris and New York. That is the invisible weight of our daily messages. And if we zoom in on just one of these facilities, a single large data center can burn through as much electricity in one day as a small city of 30,000 people. It's just an almost unimaginable thirst for power, and that power has to come from somewhere. So that's the big question, isn't it? Where does all this power come from? We imagine the internet as this clean, modern, almost ethereal thing. But when the cloud actually touches the ground, the reality can be very, very different. This quote from Gary Cook at Greenpeace just hits the nail on the head. When you think of the internet, you don't think of coal, right? It's the last thing that comes to mind. But in the desperate search for cheap, constant power,
Many of the world's biggest data centers have been built right next to a 19th century power source, old-school, carbon-spewing coal plants.
And this really exposes this deep, deep contradiction at the heart of Silicon Valley. The image they project is all about a clean, green, virtual world. Electric cars, organic food on campus. But the reality for many of their giant data centers, especially in states like North Carolina and Virginia, is that they're plugged directly into a power grid that is dominated by cheap, polluting coal.
And how do they get that cheap coal? Well, often it's through a process called mountaintop removal. And yeah, it is as brutal as it sounds. They clear-cut ancient forests, then they literally blow the tops off of entire mountains with explosives to get to the thin coal seams inside. All the leftover rock and toxic waste, they just dump it into the nearby valleys, burying streams forever.
To date, over 500 mountains in the Appalachians have been flattened this way. 500. These are geological formations that will never exist again. It's a permanent scar on the landscape, and it's driven, in part, by our 24/7 demand for digital services.
This is what a local resident said after seeing what happened to a mountain she grew up with. You can hear the disbelief in her voice. It's not just some abstract environmental issue. It's deeply personal and devastating for the people who live there. That shock she's talking about, that's the real human cost of the cheap power that keeps our digital world humming.
So, yeah, it's a pretty grim picture. But if there's one thing the tech industry has always been about, it's disruption, right? It's about innovation. So the huge question now is this: can the very same industry that created this massive energy problem also engineer the solution?
And the big tech companies are starting to move. Google built a data center in Finland that uses freezing seawater for cooling. Apple built the country's largest private solar farm to power one of its facilities. These are awesome first steps, but they've all run headfirst into the one big problem with renewables: intermittency. A data center needs power every second of every day, but the sun doesn't always shine and the wind doesn't always blow.
This challenge has led to a really fascinating and revolutionary idea, one championed by the economist Jeremy Rifkin. He calls it the Third Industrial Revolution. And the concept is actually pretty simple, but it's also profound. What if we use the internet's own model, this distributed, collaborative network, to completely remake our energy system?
See, right now, our power grid is basically a one-way street. Giant power plants at the top push electricity down to us, the consumers. It's a pyramid. A smart grid flips that completely on its head. It's a network where homes and businesses can both produce their own renewable energy and then use the internet to share it with each other, based on who needs it and who has extra. It's a shift from a top-down pyramid to a collaborative web, just like the internet itself.
And that brings us to the final, big question. The future of data is growing exponentially. So where do we go from here? Will we innovate our way to a cleaner future, maybe even turning servers into connected home radiators like some startups are trying to do? Or will the sheer, unstoppable growth of data keep us chained to 19th century fossil fuels? The choice we make for our virtual world will absolutely define our physical one.